Good afternoon, students. Here we have a problem 81 from chapter 5. I got a request from one student to solve this problem and show the solution. Now, the easy way, if you know the formula, then you can just plug the numbers and you get the answer. But however, if you don't know that one, then you have to go through many steps to get the final formula and plug the numbers to get the answer. Now, in this problem, we have the y height, which is given here, which is 2 meter, and we have infinite long charged rod. The linear charge density is given, which is 4 times 10 to the power of minus 6 coulomb per meter. We have to find electric field at a distance of 2 meter, okay, which is a y distance. Now, okay, so let's start then. First of all, we have to take any point or any fragment or small piece of this charged rod. Let's say this is a dq. Sorry, dq. It will be very small, at the distance of any x, and this will I call it dq. Okay, very small charge, and the length of this dq is dx, which is also very small, and this dq will create electric field, okay, at point P, which is shown here, which I call it dE. dE means very small electric field. Now, then, and this dE at a certain angle, any theta, okay, let's call it like that one. Then we can see here that dE can be resolved into two components, okay, before moving on. It can be resolved in a dy, and it can be resolved in a dx. You have already probably seen similar problems where if you take the same distance, small fragment of that one at the same distance, then what will happen is that it will create an electric field, okay, this one, let's call it dE. So dE will also make dEx and also dEy, okay, and as you can see here, dEx has the same magnitude but opposite direction, so therefore they will cancel each other. At the end, what will happen is that only dEy's, okay, only dEy's will be add up, okay, when you integrate it, okay. So that means we have to find only dEy. Now, then let's start slowly with the formula, then bits and bits we will go there. The first formula that we have to use it is electric field, very small electric field, dE that is coming dq is equal to the 1 over 4 pi epsilon naught dq over a distance. So in this case, that distance I'll call it r, okay, so let me call this one r. This is a distance between the charge until the point P, okay, so divided by the r squared, okay. Then what is next formula? Okay, so let's find r is equal to what here. R is equal to the x squared plus y squared under the square root, right? Then dq is equal to what? dq is equal to the lambda times dx, okay. dx is just the length of the dq. Then what else? Then we have this is a theta, right? So this is a theta. Then we know that when we are finding dEy it will be equal to dE multiplied to the cosine theta, okay. Why is that? Is because this is theta and this is theta also. So that means if you want to find dEy, then dE multiplied to the cos theta, okay. So then cos theta, we can keep it there. I think we don't need it right now. Then what else? Then we can say that we have a tangent theta, right? If you take that theta, tangent theta will be equal to the x over y. And if you want to find x, is equal y times tangent theta, okay? I just want to write it down because we're going to use those things, okay? Then what else? Now, so let's continue. Continue here. So let me just write it down here, dey. So de is equal, so for now let's keep it as a de, then 1 divided by 4 pi epsilon naught. dq was equal to the lambda dx, right, divided by the r squared. Okay, now you see here we have a dx, right? So if you have this equation where x is equal y tangent theta, if you want to find derivative of x, then what will I get it? If you take the derivative of that one, you should get y sec squared theta and d theta, okay? Then what else? Okay. So then we know that if you take this one here, then we know that x squared plus y squared, right? And we want to replace this x, okay? This x, we'll plug it here. Then what we'll get? We will get y tangent theta. This is a squared plus y squared, right? Then what we will get? Then after that we will get that y squared tangent squared theta plus y squared is equal then y squared tangent squared plus 1. Now tangent squared plus 1 will give you sec squared theta, so that means we can get y squared sec squared theta, okay? So all those things will okay, let me just highlight it with that one so that we can know that it's related to all these things, okay? Then now I think we can continue, right? Then after that we wanted to find dey is equal de times cos theta, right? So then we can say that dey, now de is equal 1 divided by 4 pi epsilon naught multiplied lambda, then dx was equal to what? Dx was equal to the dx was equal to the y sec squared theta d theta divided then this is lambda dx, then r square was equal to what? R square was equal to the r square was equal to the x square plus y square, which is this guy, okay? Then what else? Then we know that x square plus y square was equal to the y squared sec squared theta, right? So let's continue here. 1 over 4 pi epsilon naught multiplied lambda. By the way, we are forgetting here cosine theta, okay? Because we still have cos theta, that one. Then lambda y sec squared theta, then cos theta d theta divided by x squared plus y squared was, in our case, was equal to y squared sec squared theta, right? Then what else? Then we can see that some of them can be cancelled out. So this will sec squared with sec squared theta will cancel out. Then y squared with 1 as a y will be cancelled out. Then we will end up with dey is equal lambda cos theta d theta divided by 4 pi epsilon naught y, right? Then after that, we want to integrate it since we know that our root is infinite. So this will be the negative infinite. That one will be a positive infinite, right? But however, if we have cosine theta, we want to integrate the angle, then you can say that the integral of both sides will be equal. Then the limits will be minus pi over 2. This one will be pi plus over 2. Okay, you can solve this problem in two ways. One will be putting the limits like this one, or the second way will be actually you take the half of the root. This one, if you take the half of them, then you can see that it is dE integral 2 times, because you have to multiply it by 2, right? So 2 times lambda cos theta d theta divided by 4 pi epsilon naught y, and limits will be from 0 till pi over 2. Okay, this is another way of solving, but however we will stick with the one which we are solving it here. So then we can, just for a moment, then it's equal. Now after the integration, after the plugging the numbers, you should get that it's equal to the lambda 2 pi epsilon naught and y. Okay, now let's plug the numbers. Our lambda was 4 times 10 to the power of minus 6, right? 4 times 10 to the power of minus 6 divided by 2 pi, 8.83, I think 85, times 10 to the power of minus 12, I think, or 8, I really forget it. Then y was 2 meters, I think.